Okay, so I want to give you a little bit of time to maybe work on the project. So I want to go through this, some of the things that you're going to be doing on this project. And one is to sketch a scatter plot and then calculate a line of best fit and then use that line to make predictions. And so we're going to build on a little bit of that previous example that we've done. So you're going to need your calculator for this. And these instructions are in e-learning, tells you everything that you need to do to sketch a scatter plot and draw the line of best fit and calculate this statistic that we're going to look at called the correlation coefficient. It's something that you'll study a lot more if you go on to statistics. But we're primarily just interested in the steps A through E here. All right, I want to take just a small example and I'll go through it with you. All right, so here's our first data set. And what we're going to do, it consists of just 4 points. If you look at, there's 4 rows here. And a lot of times they give the X and the Y in 2 columns. But if you were going to plot the point, you would plot the first ordered pair dealing with millennials. They asked 2 questions. And they said, would you try sushi? And 42% said, never, won't try it. Don't like it, won't try it. Well, that means 58% said yes, they would try it. And then the other question they ask is, do you approve of marriage equality? And 36% said, no, I don't. I don't approve of marriage equality. So those were the 2 questions, and they asked a bunch of millennials those questions, and this was the average response. And they asked Gen Xers, boomers, and then the silent generation, the greatest generation, the generation before the boomers. Okay, so what we're going to do is we're going to get these 4 points, and we want to plot them on our graphing calculator screen. So what we're going to do is we're going to put all of the won't try sushi numbers into a list called L1, and we're going to put all the don't approve of marriage equality numbers in a second list in L2. And then we're going to tell the calculator to sketch the scatter plot. So here's how you do it. All right, so the first thing you want to do is to go enter in these 8 values into your calculator. So the first place and where you're going to be going for most of this is in the stat menu. So I think maybe we've been here before, but so you're going to hit the stat key. And if you're going to enter data, that means edit your data list. You want to select this first option. To calculate, we're going to go there. That has a bunch of commands in there where you can calculate something. And we're not going to use this menu over here. So the first thing you want to do is under the edit menu, you want to select the first option, edit. So just hit enter and you'll see some lists. Your lists may look different than my lists. If you have stuff in your lists like I do, if there's just a couple of data values, you can hit the delete key to delete them one at a time. But you want to clear out all the lists, both L1 and L2. And then you're going to enter in these 4 numbers into L1 and then these 4 numbers into L2. So if you have a bunch of stuff in a list, you want to get rid of it all at one time. You need to move your arrow keys so that you're highlighting L2. And then you're going to hit the clear key right here and then enter. And it'll wipe out that entire list. All right, so I'm going to move over to L1 and I'm going to enter in each one of these values, 42. After each one, I'm going to hit enter and it'll just go right down the list. So you see the 42, 52, 60, and 72 in list 1. I'm going to move the arrows one to the right and I'm going to enter in the don't approve marriage equality numbers, 36, 49, 59, and 66. So you can see from looking at other examples here, sometimes you have many more data values to enter, but we're after a graph that looks a lot like our previous example, this one right here. It had 4 points to it. Okay, everybody good on that? Okay, now the next thing we have to do is we have to tell the calculator that we want it to draw this graph, and it's got to be a scatter plot. So right above the y equals here, there's this command that's called Scatterplot, and that refers to a statistical plot. And the Scatterplot is one of the plots that your calculator can construct for you. So what we're going to do is we're going to hit the second key so that we go into the stat plot menu. Second, and then y equals. And here's what you see. It's a menu. You have 3 different plots that you can turn on. Number 4 just says turn them all off. So let's go where the cursor is highlighting L1. Let's just hit enter. And then it takes you into this screen where you can turn on a scatter plot. All right, so the first thing you want is, if your calculator has off there, and most of them will, when the cursor is blinking on the word on, you have to hit enter so that it switches to on. So you want to turn this plot on. Go down 1 with your arrows so that you have an opportunity to select the type of curve. It can select a histogram. It can select this graph here, which is a box and whiskers plot. Here's another box and whiskers plot. This one looks like an ogive. The one we want, there we go, is this one here. This is the scatter plot icon. So move your cursor so that you're highlighting the scatter plot icon and hit enter. So that's the one that's going to be selected. Down here, when you select this graph, it understands that you're going to plot a bunch of ordered pairs, x's and y's. So it's going to ask you what your x list is and what your y list is. So if your list does not say, let's say it says L6 or something instead, well, you don't have any data in L6, so you need to change that to L1. Now, all of the list names are right above the corresponding numbers. So L1 is right above the number 1, L2 is right above the number 2, L3 is above the number 3 and 4 and 5 and 6, so on. You got 6 different lists. L6 is above 6. So if I want to change X list to L1, I would hit the second key and then the number 1, and it would change it to L1. Okay, and the Y list should be L2 because that's where we put our Y values in L2. Okay. L2, Y values, L1, X values. And then you can select a mark. And I always select the big rectangle there because it shows up better on the graph. But you can also select a plus sign to represent your points or a dot to represent your points. There are 3 different dots because you can construct 3 different scatter plots at the same time. Okay, so we have the data in there. We have the plot turned on. Go ahead and hit Y equals, and you should see that plot 1 is highlighted. Now I have some other stuff in here, so I'm just going to clear it out. So you want plot 1 highlighted. Nothing else in here for now. And now, after that, you're going to want to go to the zoom menu because we now have to set the viewing dimensions. Usually our viewing rectangle on the graphing calculator might go from -10 to 10, -10 to 10. Well, if we do that, we're not going to see these points. So we have to change the window so that we can see all these points. The easiest way to do that is to go to the zoom menu, press the zoom key, and then go all the way down to number 9. Number 9 is zoom stat. And what this function does is all of these zoom commands change the viewing rectangle. This particular one goes and peeks at your plots that are turned on, and then automatically sets the x-axis scale and the y-axis scale so that you'll see all of your points. So it's the easiest way to see all of your points. After you get your data entered and your plot turned on, just come to zoom and hit zoom 9. All right, so I'm going to hit 9 here, and then there's the scatter plot, and you see the 4 points. What you can see here as 1 increases, the other variable increases. As x increases, y increases. So they kind of go together. Those individuals that say they don't like sushi correlate strongly with those who say that they don't approve of marriage equality. So here's your scatter plot. Okay. Now, if you remember what we did over with this one, they gave us the scatter plot. So what you're going to do in these problems in the later sections is you're actually going to construct this scatter plot. Not only that, you're going to find the equation of this line, or you're going to tell the calculator to find this equation of the line for you. Okay, so we want to find what is called the line of best fit. It's not going to be a line that goes through these any 2 points, but it's going to be the mathematical line of best fit. It's the line that has been shown to be the closest to all the points when you consider them together. And what it does is it just looks at the distance from the point down to the line, wherever the line is. And that's called a residual, or a distance between the point and the line. And then they square those residuals, and some are positive, some are negatives. And the line that it finds is the one that leads to the smallest square, sum of the smallest squared deviations from the line, squared residuals. So, but all that's done behind the scenes. You just want the equation. So here's how you do it. The calculator will calculate the equation of the line. And when it does that, it calculates the value of the slope, the numerical value of the slope, and the numerical value of the y-intercept. And it gives you those two numbers. You just have to throw them into an equation, and you've got your equation. So let's go to the stat menu again, stat. And now we're going to calculate something. So go over to the middle menu here. And then you're going to come down here and find something that looks like the equation of the line. Well, it doesn't have mx plus b, but it has ax plus b. So the lin is for lines, reg is for regression. So this is linear regression. And so go down to number 4, hit enter. Now, my calculator is an old one. And so the first thing you want to enter in is the X list. So you want to hit L1 as your X list. And then when it comes and asks you for the Y list, you want to hit Y2. And if it has any frequency lists in there, you can just leave those blank. It says frequency, leave it blank. And then maybe at the end of it, it'll say paste. Well, what it does is it pastes those inputs into a row on your home screen like this. And then it calculates the slope and the y-intercept for you. All right, so with this on your screen, then hit enter, and it gives you all this information. Now, what you're interested in here is, notice it's y equals ax plus b. The a is the number in front of the x, so therefore it's the slope. And the b is the number that stands out there by itself, so it's the y-intercept. Now, you might not see these two numbers, but I'll show you how to find those later. All right, so the output is y equals ax plus b, and then the calculator gives us that a is 1.0082811573, and we'll just round that to 1.008, 3 decimal places. Your calculator also tells you that the value of the y-intercept, the b value, is negative 4.467908903, and again, we'll round that one to negative 4.468, just 3 decimal places. Okay, then we're going to put those two numbers into our equation. So the a value is 1.008 times x plus b. Well, b is a negative, so I'm just going to write minus 4.468. So this is the mathematical best line of best fit. You can't find a line that fits those points better than this. Okay, now let's go back to y equals. And what we're going to do is we're going to enter in this equation. Y equals 1.008x. And the x key is right here, minus 4.468. Now the coefficients, the slope and the y-intercept, they're not nice, right? They're decimals rounded to 3 decimal places. But in most of our applications, that's going to be good enough. Now, we have our plot turned on, our scatter plot. We have our line of best fit. Its equal sign is highlighted. That means it's turned on as well. So we're going to plot these two together so you can actually see that the scatter plot, all you have to do is hit graph, that the scatter plot, and you can see that line goes right through the middle, right through the heart of those points. A couple of points above the line, a couple of points below the line, but it goes right through the middle. And that's called the line of best fit. It's also called the least squares regression line. And that's where you get linear regression, which is an advanced topic in statistics. But now we have an equation here. So we can use that equation to make predictions. Okay, so if you get an error, yep, we'll get the R's. Dimension mismatch, that's going to see. Okay, I can't seem to figure out. Okay, so I'm seeing some comments in the chat here. No zoom option. Okay, I can say something a little bit about dimension mismatch. So first we'll go back to stat. Now, it's important that the number of x coordinates you have matches the number of y coordinates. If it doesn't, then that's one way you'll get a dimension mismatch. So if you see 4 here and you see 4 here, then you shouldn't get that error. And this line means there's nothing underneath those. Now, the other thing is that when you set up your stat plot, when you go to stat plot, you have to make sure that your X list is L1 and your Y list is L2. Because if they're not, you might be using L1, that list that has 4 values. If you're using, say, L3 that has just 2 values in there, it's going to try to create points with 4 X values, but only 2 Y values, and it'll give you that error. All right, so Wesley, you can zoom option other. No zoom options on the calculators right here. This zoom doesn't show up. I'll let you know how to get the R's here in a second. Okay, so Tasha, let me know if you figured out your problem. And CC after I hit L1. So make sure this is L1 and not this is L2. Tasha, I think I can, if you would follow along with me, if you hit the stat key. All right, so here's what can happen. I come over here and I want to delete out 42 and I hit delete here. Well, what happens if I hit delete here, I don't have L1 anymore. It's gone. Looks like I deleted it. Oh no. It didn't delete it, however, it just hid it. So it's hidden. So here's what you have to do to bring it back. Go to stat and then go all the way down to setup editor, number 5. So press number 5 so that it comes to your home screen and then hit enter. So this kind of sets the display screen back to default where you have L1 through L6. So it doesn't look like much happened here, but if you go back to stat and then edit, then you're going to see those values come back. All right, so here's a kind of some generic questions that you'll be asked on just about all of these. Sketch a scatter plot. You'll do that with the calculator, and you can plot that scatter plot right on your graphing calculator. You'll use linear regression capabilities of your graphing calculator to calculate the correlation coefficient. So that's where we're going next. Correlation coefficient is the R. And then what does that tell you about the relationship between the two variables, X and Y? And then it'll ask you to calculate, use the linear regression capabilities to calculate the equation of the line. We've done that. Y equals, I forgot what it was already, 1.008x minus 4.468. And then it says to interpret the slope. What does that number mean? And interpret the y-intercept. What does that number mean? And then describe the trend. So we would say as the x value increases, the y value increases. As generations become more and more open to eating sushi, they also become more and more open to allowing for same-sex marriage. Is that what marriage equality? Yeah, marriage equality. All right, then you're going to be asked to make some predictions. So using the equation of the best fit line, predict the x value when the y value is, okay, let's just do a y value equal to 50. And then let's predict the x value, so the x value is 50. Let's predict the y value when the x value is, say, 70, something like this. And these problems will be given to you, but depending upon the context, 50 and 70 might make sense in this example, but it might not make sense in one of these other examples. So let's do part G here. We're going to use the equation of the best fit line, that's this equation right here, to predict the x value. So find x when y is equal to 50. The numbers will change, but you're going to be making predictions for x and predictions for y. So we're going to take our equation, y equals 1.008x minus 4.468. And we're going to replace the y value in that equation with 50. This creates an equation that we can solve. So let's go ahead and solve it. We're going to get this term off this side by adding it to both sides. And that requires us to add 50 and 4.468, this number. And then finally, we're going to divide by 1.008 so that we get x by itself. And then to evaluate this, I'll get the calculator out. 54.03, I'll round to right there, 6. 54.03. So if there happened to be a generation in which 50% said that they support or they're open to marriage equality, then we would expect the 54% of that same generation to be willing to, or to say that they have no use for sushi, or they're not a fan of sushi. They won't try it. The other one's a little different, because in this one, we're going to predict the y when the x value is 70. We'll find the y when x equals 70. Turns out that this one's even a little easier, because we're going to start with our equation, 1.008, but instead of writing x, we're going to write the value that x is equal to, 70. And for this one, all we have to do is to punch this into the calculator and evaluate, 66.092. So we would say that if we had a generation for which 70% won't try sushi, then we would expect that same generation, whatever it happened to be such that 66% would not approve of marriage equality. So we're kind of linking the x and the y and making predictions from the trend that we've observed. Okay, one thing that I do have to share with you is what this correlation coefficient is all about. So that's where I'm going next. And then I'll show you how to get it on your calculator screen. Okay, so when you, just so you know, when you go to Newton and they're describing this correlation coefficient, the formula is just unbelievably difficult. You might not even understand, you know, what you would do with the formula. It's got a lot of symbols like this in it. It means a summation in mathematics. But you're not going to have to calculate the correlation coefficient from a formula, so don't worry about that. We're going to allow the calculator to calculate this number for us. And here's what you need to know about this number. It's a number just like the slope is a number. And if we knew what the slope was, we could maybe say something about the relationship. Same thing here. If we knew what the correlation coefficient was, we could talk about the strength of the relationship between the two variables, x and y. So we're going to have a scatter plot. And the scatter plot, a lot of times with real data, all the points are not going to perfectly fit on one line, but you might have an observable trend. It's kind of an upward trend on this one. The correlation coefficient tells us what the strength of that linear relationship is. And so if we threw a line of best fit right through the middle, it would look something like that. There's our line of best fit. We'll go right through the heart of the data. All right, so here's how you interpret the correlation coefficient. First of all, you need to know that the only possible values of a correlation coefficient are numbers between -1 and 1. That's it. If r was equal to 2, there would be an error somewhere, because r can never take on a value larger than 1. You might remember probabilities were this way, right? Probabilities have to be numbers between 0 and 1. You can't have a negative probability. You can't have a probability larger than 1. All right, so let me show you what the scatter plots look like for different correlation coefficients. Here's the continuum. The largest value or the smallest value of r would be -1, and the largest value of r would be +1. The scatter plot, if the correlation coefficient is -1, this is what the scatter plot would look like. It would be a perfect linear relationship. All points would fall on the line. None of the points would deviate from the line of best fit. That's what it would look like. Perfect. Over on the other side, a correlation coefficient of 1 would be the same thing, except, excuse me, except you would see a positive sloping line like this. But the line of best fit, every point would fall on that line. So again, you have a perfect linear relationship. Now let's contrast that one with the scatter plot right in the middle. That would be when R is equal to 0. If R is equal to 0, then the scatter plot that you will see, there will be no observable trend at all. These points will just be all over the place. There's no upward trend, there's no downward trend, there's no relationship at all. Okay, so the numbers between 0 and 1 then would indicate positive trends, and what that means is that you've kind of got this upward trend. Maybe I should say upward. The correlation coefficient, if positive, would suggest an upward trend, and that's the same thing that the slope does. If the slope is positive, you're going to have an upward trend. So the slope and the correlation coefficient will have the same sign. All right, so let me draw maybe like R equals 0.8. It's going to be an upward trend because the correlation coefficient is positive. But if this is a line of best fit, you're going to see some points deviate. But with a correlation of 0.8, it's still going to be a fairly strong upward trend relationship. You might have 1 or 2 points a ways away from the line of best fit, but not many. You're basically not going to see too many points in this upper and this lower triangular region. Everything is going to be, all the points will be up through the middle in this trend channel. If you had something like R equals negative 0.6, something like that, well, the first thing you're going to notice is it's going to be a downward trend because of the -6. But these points are probably going to fall much further away from the trend line. So it's kind of a wide trend channel, much wider than say this narrower one over here. And you might see more than one point in that upper triangular area or the bottom, the lower triangular region. So 0 is no relationship. And as you go from 0 to 1, the relationship becomes more and more linear, upward linear. So you get to +1, and then it's a perfect linear relationship. As you go from 0 to -1, you'll see, well, maybe I should go this way, from a perfect relationship, and as you get closer to 0, the points get further and further away from the line of best fit. So you have this kind of wide trend channel here. All right, so here are some examples. This one here, you can see that it's a positive increasing relationship, positive, positive. This one here, wider trend channel, but positive. And this one, they're all over the place, no correlation. Yeah, I would disagree with this number here. This would be probably closer to 0.7, but that's okay. This one over here, you can clearly see a downward trend. And you establish this lower triangular region with no points and this upper triangular region with no points. This is going to be closer to -0.6. And then -0.8, see this downward trend channel. And if it's a perfect linear relationship, -1. Here are some examples of scatter plots. Go ahead and write what R is equal to on each of these. What does R equal in each case? Guess, estimate. First thing you want to decide is if it's a positive R or a negative R. If it's an upward trend, it'll be a positive R. And if it's a downward trend, a negative R. See that? Positive, 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 upward trend. Negative, 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 downward trend. The points are all in a row, perfect relationship, 1 or -1, depending upon whether the trend is upward or downward. Okay, let's take a look. This one here, all of these lines fall on the same line, on the line of best fit, but it's a downward trend, so this one would be -1. This one, perfect linear relationship increasing, +1. This one here, you've got this very skinny upward trend channel. This is probably 0.9. Down here, you have this negative trend channel, and all those points just kind of fit on this in this very narrow. So this is a downward trend, so negative, probably about 0.95 even. This one here looks like it's even skinnier than this one. This would probably be 0.95 because of the upward trend channel. And this one here, you know, if you just kind of, you know, I mean, if you're going to have an upward trend channel, then maybe it would look like that. A downward trend channel, it would look like that. But I'm not sure we see either of those two there. So this is going to be very close to zero. No upward trend, clear. No downward trend, that's clear. If you're going to answer these questions, which scatterplot indicates a perfect negative correlation? Okay, that's A. Which scatterplot indicates the perfect positive correlation? That would be B. Which scatterplot is R equals 0.9? Okay, I would say maybe your choices are C and D maybe. Those are probably both pretty close to 0.9. And the one that's probably close to 0 would be E. Okay, let me show you how to get this on your calculator. Now, you've seen in our example that these points all kind of are on an upward trend, and all of them are very close to the line of best fit. So this is going to be a very, you know, 0.9, 0.95, 0.99, something like that. Very, very close to one relationship because these points are so close to the line of best fit. Now, when I calculate and I use this linear regression function and I hit enter, it gives me R. R is the last thing here, and you can see it's 0.98. So very, very strong R. So for this one here, R is equal to 0.982. This is the correlation coefficient. So in a problem that asks, what is the correlation coefficient? Then we would say it's equal to 0.982. Okay, some of you do not see R yet, so let me show you how to find it. You need to set the diagnostic on. It's a one-time function you have to run. After you do this, you'll never have to go back to it. But set diagnostic on is not used a whole lot, and so it'll appear in the catalog. The catalog of your calculator has a listing of all the functions that it has. So we're going to hit the blue key to get to it, and then 0, second, and then 0. And this is what it looks like. Okay, you want to scroll down until you see diagnostic on. And it's alphabetized. So diagnostic on is what you want. There are different diagnostics, but probably on this calculator, but the R is the only one I know of. So just make sure that the little arrow is pointing at diagnostic on, and then hit enter. Now diagnostic on will go to your home screen. To execute that command, you have to hit enter again, and then it'll say done. That's it. Every time you now run linear regression, AX plus B, it's going to give you the R. Let's look at an example. This is world literacy and undernourished. So they have a bunch of countries there. They didn't list the United States, but in the country, say in Cuba, what percentage of the population is literate? What percent of the population can read? In Cuba, 100% of the population can read. What percentage of the population are malnourished? 2%. All right, so go to y equals, and then you have to have your plot turned on, and you have to have this equal sign turned on, and then you type in your equation. So with the equal sign on, it means it's going to graph the line. With the plot turned on, it's going to graph the scatter plot. And then once these are good to go, you just hit the graph key right here. So Tasha, you can only see set diagnostic on the screen. If you see anything at the beginning of diagnostic on or at the end of diagnostic on, then it's going to give you a problem. What I want you to do is I want you to find the line of best fit, and I want you to find the correlation coefficient. So once you have the line, then graph it with your scatter plot. Anybody else having difficulty other than Wesley and Molly with their phone app? Well, in this case, you have many more X's to enter in. So you can clear those out, or you can just type over them, 100 and then 71, 36, and so on. All right, so make sure that the 100 goes with the 2, and then 4, and then so on. And make sure that you have the same number of L1 values as L2 values, same number of X's as Y's. If you don't, then the calculator will give you a dimension mismatch error. If you get lost outside of class, just remember you have this sheet. What I'm showing you is this sheet. And it just takes you through all of everything that we did. Here's the Zoom 9, then Regression, and so on. And you can ignore these down here. All right, so if you think about this, they say that if you want to bring people out of poverty, just educate the mothers. And I think this is just one example of just one small piece of data that can illustrate that. So this is, you can see in Ethiopia, you have a larger percentage that are illiterate because only 36% are literate, which probably means that they don't allow girls and young women to go to school. And because of that, you have a very large percentage of undernourished children. So as you educate more, the undernourished rate goes down. And you should see this in your scatter plot. Okay, so you can see mine, I kind of left over this equation I didn't get rid of. So I'm going to clear that out. So here's the scatter plot, and here's one where you have a negative relationship, because if you draw the line of best fit, you'll see that that it's certainly a downward trend. So as X increases, as the percentage of individuals become literate in a society, that the undernourished rate goes down. As X increases, Y decreases, and you see this trend. And so this is going to be a negative sloping line, so that's why you see the negative 0.554 X, and then the Y-intercept 55.621, and then the correlation coefficient is the same sign as the slope. So if the slope is negative, the correlation coefficient is going to be negative. They kind of are positive or negative together. All right, so the last thing you might want to do is to put the new line of best fit in here, and then graph the scatter plot along with the line, so that you can see there's the line of best fit. Kind of goes right through the heart of the data. Some of the points are below the line, some of the points are above the line, some of the points fall right on the line. But this is what it looks like. And there's a bunch of points in here that are kind of grouped together. Very high literacy rate and a very low undernourished rate.